Good morning, sir. Myself, K. Bhuvan. Currently, I am pursuing my bachelor's in Srinivasa Ramanujan Institute of Technology. Today, I am going to explain a topic in strength of materials, mechanical properties of materials. Introduction to mechanical properties. Mechanical properties describe how materials respond to applied forces and loads. These properties are essential for selecting materials in engineering and design. Understanding them helps predict material behavior under different conditions. Stress and strain. Stress is the internal force per unit area within a material caused by external loads, and it is denoted by sigma. Formula is force per area, Newton per mm square. Strain is a deformation or elongation experienced by a material in response to stress. Stress is change in length by original length. The relationship between stress and strain is fundamentally analyzing material behavior. Young's modulus equal to stress by strain. Elasticity and plasticity. Elasticity is the ability of a material to return to its original shape after removal of a load. Plasticity refers to a permanent deformation that occurs when a material is stressed beyond its elastic limit. The elastic limit defines the maximum stress a material can withstand without permanent deformation. Young's modulus, elastic modulus. Young's modulus measures a material's stiffness in the elastic region. It is calculated as the ratio of tensile stress to tensile strain within the elastic limit. Materials with a high Young's modulus are generally stiffer and less deformable. Yield strength and ultimate tensile strength. Yield strength is the stress level at which a material begins to deform plastically. Ultimate tensile strength is the maximum stress a material can withstand before fracture. These properties are critical for designing materials that can sustain specific loads. Ductility and toughness. Ductility describes a material's ability to undergo significant plastic deformation before breaking. Toughness is the ability of a material to absorb energy and plastically deform without fracturing. Both properties influence how materials behave under impact and load conditions. Hardness. Hardness measures a material's resistance to localized plastic deformation, such as indentation. Common hardness tests include Brinell, Rockwell, Vickers method. Hardness is an important indicator of wear resistance and durability. Fatigue and creep. Fatigue refers to failure caused by repeated cyclic loading, even if the stress is below the ultimate strength. Creep is a slow, permanent deformation of a material under constant stress at high temperature. Understanding these phenomena is vital for components subjected to long-term or cyclic loads. Factors affecting mechanical properties. Material composition, microstructure and processing influence mechanical behavior. Environmental conditions like temperature, humidity, corrosion also impact properties. Proper material selection considers these factors to ensure performance and safety. Testing and measurement techniques. Mechanical properties are determined through standardized tests such as tensile, compression, and hardness tests. Advanced techniques includes impact testing and fatigue testing for dynamic loading conditions. Accurate testing provides essential data for engineering design. and quality control. Conclusion and its applications. Knowledge of mechanical properties is crucial for designing safe and efficient structures and devices. Material selection depends on understanding properties like strength, ductility, and toughness. Ongoing research continue to improve material performance for diverse engineering applications. Thank you, sir, for giving your time.